This lab is called This Little Light of Mine, and it's called that because, well, the only thing that we really need for this one is a candle. We do also have a digital balance. So the purpose of this lab activity is to practice balancing chemical equations. So these are the steps. So zero the scale, place the unlit candle on the digital balance, record the mass, light the candle, and let it burn for 5 minutes. Record the mass, then calculate the difference in mass. So I'll go ahead and I'll zoom in here. I do have this digital balance. It does go out to the 1/100th of a gram. I'm just gonna zero it because I do want to. I do want to make sure that it is completely zeroed. And the first thing I'm going to do is place that unlit candle on there to get the mass. You can see here that it says 9.26. Now I did this lab earlier and I did it with another candle, and we're going to use that data, and I got 9.81 grams. So that's the one that it's going to start. But what I want you to see here is then it says light the candle. All right. So I'm just going to make sure. All right, 9.27. All right. So I'm just going to light the candle. And we're going to let this burn for 5 minutes. Now, I'm not going to let this one burn for 5 minutes just for the sake of time. I've already done that. But what I want you to notice is, look what happens to the mass. We'll let it burn for about 20 seconds or so. So it started at 9.27. It's now down to, it's going down, 9.23. You can see that now it's going to go down a little bit more. What was that, 9.2? There we go, 2.3. All right, so I'll let that go. I'll let that burn for a little bit while I explain that, and then we'll go back to that just to see what the mass is. So you're going to let this burn for about 5 minutes. Here, I'll get the mass in there because you can see it slowly go down, like in the hundredths of digits. Now 5 minutes. I've already done that. I did that with the original candle right here. And like I said, with this the original candle, it started out with a mass of 9.81 grams. So that's what I'm going to use for this lab. So that's what I recorded there. It's you can see here, yeah, it's burned for a little bit. You can see that the mass has gone down now. So it started at 9.27. Now it's down almost a whole tenth of a gram. So that's the idea behind this. The mass should slowly be going down. So after 5 minutes, what you can do is you can extinguish the candle just by blowing it out. There you go. All right, then you're gonna find the mass after it's burned. So I'm gonna put this one on. Like I said, this is the one that I did earlier, and I've already burned this one for exactly 5 minutes. Started at 9.81 grams. You can see here it's already zero. Just for good practice, I'm going to zero it again just to make sure. Then I'm going to go ahead and place that on there. And it is at 9.51. All right, so we'll say 9.51. All right, so now I need to find the difference in mass between before when I started burning it and after I burnt the candle. So it says it was at 9.51. Well, I just set up, minus 9.51 grams. That's actually a fairly easy problem to do, but that's how I do that. I get my starting mass, subtract the ending mass after 5 minutes of burning, and you can see that it did go down just a little bit. All right. So now let's take a look as to why this is. So when a candle is burned, the paraffin wax plus oxygen react in a combustion reaction, which yields carbon dioxide and water vapor. It is an exothermic reaction, which means that energy is transferred to the surrounding during the reaction. This can be seen and felt in both light and heat. For each molecule, record what part of the equation is. So when you burn, here I'll burn this one because this is the one that we did already. So I'm burning this. This is a combustion reaction. So this is what's happening. Here, this is the reaction right here. I'll scoot in. I don't want to burn the paper, but this is the reaction. So what happens is candle wax right here is paraffin wax. Now it is a combustion reaction, which means it's reacting with oxygen, and it forms carbon dioxide and water vapor, and it releases energy into the surrounding. So you can see here at each of those I did put the state of matter. Now the reason H2O, or that water, is a vapor is because, I mean, it's hot. You can feel the heat. You can see that energy being released, and when the water is created during that exothermic reaction, it's hot enough that it is like a water vapor, and it does release carbon dioxide. So in each one of these, you do need to know, well, what part of this equation is the reactants and what part are the products, and what state of matter. So on these, the state of matter is already put there. And to figure out why the scale, the number went down, you need to answer this next question. So the law of conservation of matter states that in a chemical reaction, matter is neither created nor destroyed. However, when the candle is burned for 5 minutes, the mass of the candle goes down. So it all goes back to this. Why? And here's a little hint on this one. Well, what state of matter or states of matter is the scale able to read, right? So why is it that we just saw the mass go down, and even though, well, we cannot create or destroy matter. All right, so the last part of this is, you can see here, I left off the coefficients to this equation. And that's because you are going to balance this equation by messing with the coefficients. Now remember, we cannot do anything with the subscripts to any of these chemicals. So like the example, I'll start this off for you. The first thing I say is balance the carbon atom first. That's the hint, right? So balance the carbon atoms. Paraffin wax, you can see here, has 25 carbons. Carbon dioxide over here only has 1 carbon. So you can only change those coefficients. So you can start off there, and you can already sort of tell how that balancing that equation is going to go. So once again, this is the lab. Call it This Little Light of Mine.